Yeah, so it's a minute to 5 o'clock. So let's ensure that we invite our friends from different chapters to join the call. This call will be starting, and the session will be starting in the next 1 minute. Once it is 5 o'clock, we'll start the session. Yeah, thank you. So let's share the group invite link to our friends so they can join us on time. Yeah. Yeah. So please bear with us. In the next 3 minutes, we'll be starting the session. We want to give space for people to join the call now. Yeah. So we don't want the information to just be to this participant of the call now. We want more members and attendees to join the call. Once it's 5:03, we'll start the session. Yeah. Good evening, everyone. Please confirm you can hear me. Yeah. It is my pleasure to welcome you all to today's online conference, the Modern Oil and Future Energy Conference 2026, organized by the Society of Petroleum Engineers, Southern Delta University Student Chapter, in collaboration with other chapters. I am Abubakar Alamin, the president of SP Lagos State University, and I will be the moderators of today's session. Yeah. So for those of you who are just joining this session for the first time, the Modern Oil and Future Energy Conference is an industry-focused initiative designed to expose students and young professionals to the evolving energy landscape by connecting today's petroleum industry with the innovations and opportunities shaping the future of energy. And this year's theme is bridging today's petroleum industry with tomorrow's energy solution. So on behalf of the organizers, I welcome our distinguished speakers, chapter leaders, faculty members, students, young professionals, and everyone joining us virtually today. So and I hope by now we are ready with our jotter, pen, mind for this session, because it's an opportunity for us to learn, ask questions, connect with industry professionals, and most importantly, understand where the energy industry is heading and where we fit into that future. So to confirm that you all heard what I said now, please can I get your reaction to what I just said now? Can I get thumbs up and any other reaction? Can I get that? Yeah. So the next thing on our agenda is the safety brief by Odogu Favor. Please, Odogu Favor, are you on the call? You have to give us the safety brief.
Yes, I am.
Yeah, please, can go ahead.
Okay, good evening. I am Odogu Favor, the president of SPEBTI chapter, and I'll be taking the safety brief for this session. So safety is essential in every workplace, and also we can also we can overemphasize how important safety can be, even though we're just sitting down and probably on our computers. So the safety precaution we'll be following for this particular session. Please mute your mic when not speaking. Let us ensure to mute our mic when not speaking to avoid interferences. Also, raise your hands to speak. You click on the reaction to raise your hands so you can call upon to speak. Then use the chat button, see in comments, and queue for questions. Be at alert and aware of your surroundings. So even while we are focused on the meeting and on the call, we should also try and look out for our surroundings and remain safe. Also maintain a good sitting position so that you don't feel back pains, or you don't feel you're not misaligned while on the call. And finally, always stay safe. Thank you.
Yeah, thank you very much, Odogu Favor, for this safety brief given to us. So let's ensure that we all take all what he has said in place. So right now, we'll be moving on to the next thing on our agenda, which is the introduction of guest speaker. So please, is Khalifa on the call to introduce our guest speaker?
Yes, I'm here.
Yeah, please do so.
Yes. Meet our guest speaker, Engineer Timmy Reid Zidafamor, is a petroleum engineer training officer at PTI Everon and a proud mentor to students and young professionals. He holds a bachelor in petroleum engineering and master's from the University of Bradford, UK, and specializes in reservoir development and management. He is a published scholar in local and international conferences. He is also a Quorum registered engineer and an active SPE member.
Yeah, thank you very much, Khalifa, for this introduction. Yeah, thank you. So we have speakers, we have our guest speaker ready for us today. So please, let's ensure that we have our jotters ready for us today. So take note of things that are mentioned today, write them down, because we'll also be having our question and answer session where you get to ask questions. So right now, because we don't want to waste our time, we'll be moving on to the next thing on our agenda, which is the first lecture. And the person who will be giving us the first lecture, as introduced, is Engineer Timmy. Engineer Timmy from Petroleum Training Institute. Please, sir, can you hear me, sir? Are you on the call?
Yes, good evening. I'm on the call. I can hear you.
Yeah, thank you very much, sir. So you have the floor, sir. And
okay.
Yeah, so you have about 20 minutes, sir.
Okay. 20 minutes is quite short, but we'll see what we can do.
Yeah,
good evening, everybody.
Yeah.
Yeah, can the host allow me to share my screen because I have a slide?
Okay, yeah, you can.
The host, just permit me, make me a host briefly so I can share my screen. Okay. All right. So please confirm if you can see my screen. Let me do a slideshow. Right.
Yeah, we can see your screen, sir.
Okay. Okay. Yeah. So good evening, everybody. I was introduced. My name is Timi Aredes Idafamo. I'm a petroleum engineer from Petroleum Training Institute, FRO in Warri. As some of you may know, Petroleum Training Institute is the premier um, energy institute in West Africa and Africa as a whole. We specialize in training students, young professionals, and people in the industry, okay, for usefulness in the oil and gas industry worldwide. Okay, so that being said, when I got into a discussion to get into this program, the very first thing that came to mind was to talk about the evolution of the energy industry and also to look at the future of the petroleum industry, right? Since we're looking at how to prepare young engineers and even, yeah, young professionals and students for tomorrow energy industry. So I captioned my presentation, the evolution and future of the petroleum industry that's preparing for tomorrow's energy industry. Okay, so I believe at the end of these few minutes, we should be able to know the role of the petroleum engineer and petroleum in today's world. We should be able to look at how exploration and production has changed over time. Then we'll briefly look at the technologies driving the modern industry. We'll look at some challenges facing the oil and gas industry today. And then, most importantly, we look at career opportunities in the energy transition. You know, over time, recently there has been, a lot of talk about transition. So we should be able to position ourselves as students, as young professionals, as young engineers, to be able to function in the energy transition. Okay, so let's just do a very brief background on how we got to this point where we're talking about energy transition today. Of course, we all know that from in 1859, that was when the first commercial oil well was drilled in the US for production, up to 1908, in the Industrial Revolution, production of automobiles, and so on and so forth. Then up to the 1950s, when there was a global petroleum boom, even in Africa, in Nigeria. Then up to 1973, when we had the oil crisis, of course, the prices of oil went down drastically. Then up to the 1990s, with the evolution of new technologies, we started talking about deep water drilling, offshore platforms, and so on and so forth. Up to the 2000s, where China and US started, leading the oil shale revolution, where we started looking at oil shale as an, alternative to um, oil and gas. Of course, today, what we're talking about from 2015 onwards up to today, we're still looking at digital oil fields and new technologies, right? But most recently, we've been hearing energy transition today. So, but for what it's worth, I just wanted to bear it at the back of your mind, that petroleum has evolved continuously for so many years. But at the end of the day, petroleum has still been able to survive wars, recession, price crashes, technological disruptions. Like I said, we keep hearing about energy transition. But it's important that we as petroleum engineers, we still have some comfort and solace in the fact that petroleum is still important in our world today. And why does petroleum still matter? If you look at the global energy mix globally, oil still accounts for up to 30% of the global energy in use today. While you have coal at 26%, you have natural gas, you have renewables and nuclear energy um, taking over the rest of the mix. Now, if we want to be realistic, in the world today, petroleum still matters because in most of the industries we have today, in aviation, in transportation, shipping, in petrochemicals, without petroleum, most of these industries are going to, stop functioning properly. So petroleum is, I want us as, students, young engineers, just bear it at the back of your mind that petroleum is just more than another source of fuel, right? It is the foundation of modern civilization. Okay. look around you today in the rooms that you are, you would find, one byproduct of petroleum or another. If you look at your laptops, your phones, your chair, your tables, your pens, fertilizer. Even if you want to think about it in terms of renewable energies, some parts of what's it called, the solar panel components are made from byproducts of petroleum. Okay, and so on and so forth. So still, I would still say, bear it at the back of your mind, that even though the world is gradually transitioning, right, renewable energy technologies still depend heavily on petroleum-derived materials, meaning that you as petroleum engineers, petroleum engineering students, you are still relevant in the world today. It just depends on how you choose to navigate this journey, right? Okay. Now, let us also look at how petroleum exploration has changed over the years, right? Like we know from the traditional methods, nowadays, petroleum exploration has moved, from traditional methods towards the use of AI, satellite imaging, machine learning, 3D and 4D seismic remoting. You keep hearing of things like digital twins today, even though we don't have the time, to go into them. Just bear at the back of your mind that technology is gradually taking over, the oil and gas industry, right? You have autonomous drones and robotics. Why am I emphasizing on this? This is important because as petroleum engineers, as students, we should be able to position ourselves in such a way that we are still able to play in the oil and gas industry. Okay. Aside how exploration has changed from traditional methods to the use of modern technology. Now the oil fields we have in the oil and gas industry today have gone beyond what we know, right? Because of the use of technology. Now we have the digital oil fields where most of the monitoring is done using digital tools and technologies like artificial intelligence, Internet of Things, big data analytics, cloud computing, and so on and so forth, even down to how we maintain our oil and gas facility, right? We have gone from what we call reactive maintenance now to predictive maintenance. Now, how do you do predictive maintenance? It's through, the use of data, right? Data. Okay. Yeah. So we also have, technologies like digital twins, real-time reservoir monitoring in the oil and gas industry today. Now, where I want us to focus here is, as petroleum engineers, can we also become data scientists? That's a rhetorical question, but if you ask me, the answer is a very big yes. To be relevant today in the oil and gas industry as a petroleum engineer, most especially, you have to also, double as a data scientist. You must also know how to interpret data for um, prediction, forecasting, and things like that. Now, um, if we look at production as it is today, production has also transitioned from what we know, right? Because today's production includes use of offshore FPSOs, enhanced oil recovery. We keep hearing about and deploying technologies like carbon capture, utilization, and storage, right? Yeah, CCUS, autonomous inspection robots, and so on and so forth. So if you think about it this way, all this comes together to show us that today's production with technology is safer, is smarter, is cleaner, and is more efficient. And we should also put it at the back of our mind as petroleum engineers that the world is trying to transition towards cleaner fuels and cleaner energy. So even in the oil and gas industry, most of the work that is done today is geared towards cleaner and safer energy. Okay, so now, most importantly, the challenges that are currently facing the industry today can be broadly summarized into these few points we have here, right? We have climate change. Of course, everybody, the whole world is talking about climate change, right? what is climate change? The whole essence of the climate change is to go, or rather to move towards lower emissions, right? Yes, so that we cause less harm to the environment. Okay. Then another challenge that's facing the oil and gas industry today is oil price volatility. Yes, that's because key players in the industry are worried about their investment, right? They want their investment to be certain. Now, if we also look at it from the dimension of energy security, one of the key areas to look at there is how reliable is our supply chain today, right? Environmental regulations are also, coming down heavily on the oil and gas industry because, like I said before, the world is gradually tilting towards cleaner operations, right? Then public perception, okay? How do we operate around our environment? And that then, most importantly for us in this group, right? What we should be focusing on is the talent gap in the oil and gas industry. What do we mean? The industry is still in need for skilled professionals. Okay. Moving forward, just bear it at the back of your mind as a young engineer, as a student, as a young professional, that there is a huge talent gap in the industry, right? The industry is still in need for skilled professionals. The energy transition, right? Before now, it has always been oil versus renewables, right? But as of today, the energy transition is most definitely a mix of all the available energy systems, but bearing at the back of our minds that it must tilt, towards cleaner energy solutions. So we have oil and gas and solar and wind and hydrogen and nuclear, carbon capture and storage, all working together towards the energy transition. Okay. Now, this is where I would want us to focus on. Okay. Where is the oil and gas industry going to? We have explained that, right? Yes, towards cleaner energy resources. Now, for us as young professionals, students, our minds should tilt from the traditional careers. What do I mean by the traditional careers? You want to be a reservoir engineer? Great. You want to be a drilling engineer? That is great. Production engineer, geologist, and petrophysicist, geoscientist, and so on and so forth. That is wonderful. But in the world of today, to remain relevant in the oil and gas industry, right? Young engineers should be thinking about becoming energy systems engineer. We should think about, focusing on carbon management, carbon capture and storage, carbon capture utilization and storage, right? Now we even have, some subsets of petroleum engineering towards hydrogen engineering, right? Most importantly, we should also think towards becoming data scientists. If you remember in one of the slides, I particularly asked that question: can a petroleum engineer also become a data scientist? That is very, very important in the industry today. We should be able to take data, interpret the data, appreciate the data, and also, be able to bring out meaningful insight from the data. That is what data scientists do, right? Yes. So petroleum engineers should also look at tilting, towards AI, the use of AI, automation, digital reservoir engineering, being since we're talking about sustainability in the environment, we should also look at, becoming sustainability analyst, energy economist, and most definitely cybersecurity experts. Now, in the industry today, because like I said before, I work in an organization where we get to, interact with professionals in the industry, right? We get to train them, right? Yes, and we get to, have one-on-one interface with them. So sometimes we ask them, what is, or rather, what are the skills that are necessary for petroleum engineers today? If you're fresh out of school, right, and you want to get into the job market, what skills are employers looking at? So I decided to break them down into two, right? You have the technical skills and you have the professional skills. For the technical skills, you must be able to understand your engineering fundamentals. What do I mean by that? Your basic production engineering, your reservoir engineering, well completions, well management, your reservoir management, production, what's the word, forecasting, and so on and so forth. You must know your engineering fundamentals, right? Before then, programming, for example, one of the key tools, right, that helps in the industry today is Python. We have Python, we have Excel. If you want to go a bit further, you should be able to do a little bit, of MATLAB, GIS, AI, data analytics. Very important. I keep hammering on data analytics because as an engineer, or rather, as a petroleum engineer today, you should be able to know how to interpret data, right? Meaningfully. Okay. Then the second set of skills that are very important are also your professional skills. They are very important. You should be able to communicate. What are you communicating? You should be able to communicate the work that you do. You should be able to communicate if you're given a task, right? And you arrive at, certain results. You should be able to communicate those results effectively. Okay? Leadership skills, very important. Your critical thinking cap must always be on as a petroleum engineer 247. Your problem solving skills are also very important professional skills. Adaptability. How do you adapt at work? How do you adapt to change in the work environment? Okay, teamwork. Your ethics is very important. Then, most importantly, I like to hammer on this point of lifelong learning. The industry is changing gradually, sometimes rapidly, sometimes fast. So, as young petroleum engineers, you should be ready to have lifelong learning skills. You should be able to rejig the system when necessary. Now, what should students do now? I want to believe that majority of us on this call are students. I said majority, right? What should students do now in today's world? The first thing you need to do is to build a roadmap. What do I mean? The roadmap is very, very straightforward, right? The first thing you need to do is to learn your engineering fundamentals. The essence of engineering, please do not forget, is for problem solving. So learn your engineering fundamentals. You have to keep asking yourself the why questions. The things I'm learning today, how are they relevant for me to solve problems in the industry tomorrow? So you must learn your engineering fundamentals. You must also learn the use of digital tools. Very, very important. Digital tools, either for data analytics, interpretation of data, presentation of data. Your Excel is very important, your Power BI, and a lot of other digital tools, okay? Your digital currency must be top notch. Now, as young engineers today, to learn how to study AI. AI is changing the world, okay? Study AI. You must have great communication skills. For those of us that still have the opportunity, it is very important that you gain quality internship experience, hands-on internship experience, right? As young engineers. Then join professional societies. Of course, the reason why I'm here today speaking to you, right, is because of SP, a professional society. So join professional society, speak to mentors, colleagues, your peers, people that have gone down that road before. I always tell people that I train that the easiest way for you to get something done, right, is by speaking to people that have done it before you or people that are currently doing it, right? Yes, it makes your life easier. If you have mentors, professional mentors from professional society, right, it cuts your learning journey by a lot. Trust me. Okay. Obtain useful certifications. And you can see that that's in cap. Never stop learning, right? The petroleum engineer of today has to be able to evolve, to be able to match the current challenges in the industry today. Okay. Now, to cap it up, let's just look at the petroleum industry of the future, right? Okay. What are we expecting in the future? Now, the industry for today and tomorrow is all about future prediction, production prediction, production decline prediction. There is more automation in the system today, okay? The industry is gradually phasing out manual processes. The industry is gearing more towards automation, okay? Now, the future of the industry, the industry is currently looking at AI assisted drilling operations. Now, currently, we also have remote operations. The industry is also trying as much as we can to move towards carbon neutral production, hydrogen integration. We have carbon capture, utilization and storage expansion. The industry is tilting toward digital reservoirs, smart refineries, um, autonomous offshore facilities, right, where most of the processes are automated. You need less hands offshore. And yes, most importantly, since the world is talking about um, carbon capture, cleaner energies, safer environment, the industry is also tilting towards greater environmental responsibility. The truth of the matter is people keep asking the question, will petroleum still be in the mix 50 years from now? The answer is definitely a yes. But the only difference is that petroleum will still exist, but it will look very different. Okay? Please, let us just summarize everything this way, right? Our key points to take away from this discussion should be that petroleum is still essential to global development. But most importantly, technology is transforming every single facet of the industry. That is why the future will always belong to engineers who embrace innovation and lifelong learning. Okay? Don't look at energy transition as a barrier, as a challenge alone. Energy transition creates more opportunities. What do I mean? For us to think about how to carry out the operations we carry out in the industry day to day, but then we are thinking about how to carry these operations out without causing so much damage to the environment. Okay? And most importantly, as young professional students, your career will definitely depend more on your willingness and ability to learn other than your degree alone. Yeah, it is good to have a shiny degree, but when you get out there into the industry to get your hands dirty with work, your career will mostly depend on your willingness to learn these new things that we keep talking about. Remember, the industry is transitioning every day as we speak. As a takeaway, let's just know that the future of petroleum is not about choosing between oil and renewable energy. I've said that before. It's a mix. So it is about building an integrated, intelligent, and sustainable energy system that powers the world responsibly. Okay. A rhetorical question for you to think about before you ask me any question you have, so we discuss, is I will ask the students specifically, just think about it in your own free time. If you were graduating today, which emerging skill would you invest in? Very first, will you invest in AI, data analytics, carbon management, or advanced petroleum engineering, and why? Ask yourself why. These goals have to be aligned with what is obtainable in the industry today. Thank you guys for listening. I'm looking forward to your questions.
Yeah, thank you very much, sir. So Engineer Timmy has done well. He explains to us the evolution and future of the petroleum industry. And if you enjoyed this session, please can I get thumbs up or reactions from you, firstly? Yeah. So you mentioned that petroleum is everywhere and that everything are made from petroleum and renewable energy technology depend on that. So without wasting much of our time, I'll be giving the floor to Edgar Yua to engage with us for the question and answer session. Please,
Thank you so much. Thank you so much, Engineer Tommy. It was a very powerful and educative session, I may say. And we shall go in for questions and answer. We shall do a few questions, given that I'm given only 5 minutes for this. So we should have 5 questions, and then the rest I think will come in the chat. So I'll take my question first. Thank you so much, Engineer Tommy, for the presentation. It was quite colorful. And my question is, you talked about one of the alternative maybe careers we should be looking at besides the, I may say, the official or the what we know as drilling engineering, reservoir engineering, and the rest. And you engaged so much that we should look up to careers like energy systems and engineering, carbon capture specialists, hydrogen engineers, data scientists, and the rest. My question is, and I was thinking about it on how do I get here? Because basically, in most cases, our universities teach so much of the fundamentals, that is reservoir, drilling, and maybe production. So there is less of information to us, more to do with carbon capture and maybe data scientists. So I don't know how we get so much to this. Maybe it could do with research, but if there is any other alternative, maybe supplement you could be having and what we should be engaging to so that we can get more information about this. I think you take up the questions and then answer all at once. I hope you're noting down, Engineer Tommy. Then,
yes, I am doing that.
Yeah, so I'll call upon, I think if you have a question, you can raise up your hand, mention it, unmute and mention it. We only have 5 minutes and we shall take up only 5 questions. The floor is open. You just have to raise up your hand, unmute, and give in your question. Or if you cannot give it in, you can type it in the chat, then we shall pick it from there. Should I think there is no question? I think Engineer Tommy did well. These people understood each and everything. Anyone?
Yeah, so for anyone that wants to speak, they can raise their hand so that they can be granted access to speak.
There is one in the chat. I can maybe read it. With the global energy transition, how can petroleum engineers today stay relevant? And I think the other question Engineer Tommy would be, petroleum engineers is a very big word, and I don't know, whichever person typed this message maybe needs to specify to which exact profession you would be meaning. Anyway, you can try answering that.
Okay. Okay, so yeah, are we done with all the questions? So I just take all of them at once.
Another question here, is it possible to have a sharing platform where we can be sharing the resources about programming or any other rare sources? I think that is to do with the person that organized. Maybe could continue with our WhatsApp group so that Engineer Tommy could be in there, and then he helps to share with some of the links, or the sources could be books where we can get some of this information. So in respect to other certifications, we can have to obtain an undergraduate. Which one do you suggest? He says, in respect to other certifications, we can to obtain as undergraduates. Which one do you suggest? Then the other question, I think you're also seeing this, sir, in the chat. Good evening, sir. I am from SDU chapter. My question is, how can we students learn this AI and other engineering technologies without help from our professors when the material is not available to us? I think that's the same question as mine. The sources of some of these other skills maybe we want to attain. Yeah, I think it is all around the same place.
Okay. If that's fine, moderator, let me just run around all of them, okay, as best as I can within the shortest possible time. Can you hear me?
Yes, I can hear you, sir.
All right, yeah. So I believe most of the questions are centered around how do we, get these skills to transition when they are not offered in traditional universities, right? Which is very correct. Okay, so I'll just take it this way. You can decide, to pick an interest, right, in a specific area of data analytics. For example, okay, if you're interested in learning, how to use Python, right, in petroleum engineering, I think there are there are lots of platforms online, Coursera, Petro Skills. If you want to learn Power BI, what's in it, Microsoft Learn. I'm just trying to get them off the top of my head, right? If you go online, there are free courses and paid courses on how you can learn some of these digital skills that are specific for petroleum engineering, right? That being said, some traditional universities, I know, for example, some in the UK now offer petroleum engineering with some, what's the word now? The data science option and data analytics option, right? That's for people that can maybe get scholarships or, people that can be able to afford it, right? Then, so some other thing I said, which is also very important, and let me speak freely as a young professional. The one thing I've noticed, right, about young people like myself and then students, right, is that the one error we make, and that's something I try to correct, is that if you have an interest in a specific field, aside doing the search online and all whatnot, try your possible best to have a mentor, a genuine mentor in the field. On LinkedIn, if you go on LinkedIn, if you have genuine connections and you see somebody that is doing well in the field that you would like to go in, if you understand what I mean, there's nothing wrong, with shooting your shot. Some young professionals and even people that have been in the industry for a long time can guide you, right, on how to go about um some of these things, okay? Just so that you don't get lost on your own, okay? Any other question I didn't touch? Just to be sure.
Yeah, I think what is left that is if you could be having the links or any.
Sorry, say that again.
If you could be having any links to some of these learning platforms, you could maybe share with us. Either
Yeah, we do. Yeah, we do. We have them. So probably what we'll have to do at the end of the call is the organizer can reach out to me. We have Python for petroleum engineering students. Then I remember somebody said something about short courses and certifications, right? Specifically, where I work in a training institute, petroleum training institute, we offer specific short courses for students, for young professionals that want to go into the industry or are currently in the industry. Right here, we have lots of short courses that will help you in energy transition, if that's fine. Okay.
Okay. Thank you so much. Any other question? I've just seen a question in the chat. I studied pure and applied chemistry. I want to obtain my postgraduate in petroleum-related courses. Will such be an important approach, or should I continue? I don't know whether you could take up that. Studied, applied. Yeah.
I may not want to give career advice, but You said you studied pure and applied chemistry. I want to obtain my postgraduate in petroleum-related courses. Will such be an important approach? Yes, of course. If you want to pivot is the word, right? Yes. If you want to pivot from pure and applied chemistry to petroleum engineering, it is very possible. As long as you're ready to go through the rigor of learning the fundamentals, and then yeah, you can get a postgraduate degree in petroleum engineering and probably a master's, very specific, right, to the area that closely aligns with what you already know. You should be able to do that. But that's not career advice anyways, disclaimer.
Okay, I think that is an answer to you. It could be an answer or advice as well. The other question in the chat is with the rapid integration of AI, programming, and data
Please, please, can you hear me? So, for any other questions, please can you just type it to the chat button and it would respond to that. So we want to move to the next thing on our agenda now.
All right. Thank you so much.
Yeah. Thank you very much for your time. Yeah. So, can you see my screen now? So
yeah.
The next on our agenda is the introduction of our next speaker, our next guest speaker. So I'll be calling Rachel Mocho Kirabo to give us, I don't know if I called the name correctly, sorry about that. So she'll be introducing our next speaker to us now. So Rachel, please, are you on the call now? So you can speak.
Good evening to you all. I'm here to represent Trevor Rachel. I work hand in hand with him, as I had communicated earlier with our co-host, Mr. Prince Eseka. My name is Derek Asingure, and from SPE, Chambogo, acting president. And thank you so much, Engineer Timmy, for the insights that you've given to us. We highly appreciate, and we know what you're doing is helping each and every one youth here, empowering us and ensuring that we change the initiatives, the systems of this world. Without wasting any time, allow me introduce our next guest speaker, the upcoming SPE 2028 president, Mr. Ian Phillips. Ian Phillips is a senior energy industry leader with more than 4 decades of experience across oil and gas development. Developments, energy transition, and technology innovation. His career includes leadership roles with Shell, BP, Marathon Oil, and Halliburton, where he developed extensive expertise in subsurface, wells, subsea, and major project delivery. He has also played a key role in advancing carbon capture and storage initiatives, including serving as project director for the Akon project, one of the UK's first integrated low carbon hydrogen and CC developments. He is now an independent energy transition consultant and Royal Society entrepreneur in residence at the University of Aberdeen. He is a founder of PaleBlue.Energy, now Storager, and previously served as chief executive of the Oil and Gas Innovation Center, where he led government-backed programs supporting more than 100 oil and gas industry technology projects. A chartered petroleum engineer and fellow of the Energy Institute, he is also a distinguished member of SPE, where he has held numerous leadership roles, North Sea Regional Director and co-chair of the SPE Offshore Europe 2025 Program Committee. A long-time contributor to the profession, he has served in multiple leadership roles within the SPE Aberdeen section, including twice holding the position of chair, and was selected as an SPE Distinguished Lecturer in 2021. He holds a bachelor's degree in civil engineering from Leeds University and a master's in petroleum engineering from Heriot-Watt University, Edinburgh, and an MBA from UK Open University. Ladies and gentlemen, let's applause, let's welcome our guest speaker. The floor is yours, sir. Thank you.
Yeah, thank you very much. So the floor is yours, sir. I believe we now know that we have a great person in our corner. So I'll be handing over to the 2028 SPEI president to speak to us now. Yeah, thank you.
So, ladies and gentlemen, good evening. I hope you can hear me okay. I am currently riding as a passenger in a car as I'm being driven to my next meeting. This was slightly later than I had hoped to be speaking. But very briefly, you've heard most of my career, but I wanted to make a couple of points which reinforce what you heard from Engineer Timmy a little while ago. I did a bachelor's degree in civil engineering many years ago, but I changed course and I joined the oil and gas industry and did a master's degree in petroleum engineering. But as an engineer, I also got a bit corrupted and did an MBA. So I've always in my career straddled the technical commercial interface. As you can see, I worked for oil companies large and small in my oil and gas career. But then in 2007, I changed course completely. Effectively, I left the oil and gas industry and I helped to set up a company that was trying to do carbon capture and storage. We think we were the first ever company to try and do this. And just to give you a sense of how difficult it can be, the project that we conceived back in 2007 finally got UK government financial support last year. So it took it 18 years. So you have to be very patient in the CCS business. I didn't stay with the company all of the time. I spent 6 years as the CEO of the Oil and Gas Innovation Centre, which is a government funding body. And in 2020, I returned to Pale Blue Dot, which also changed its name recently to Storegga, and I was the project director for the Acorn project. And since 2022, when I formally retired, I've had what I think you would call a composite career, doing several different things. And along the way, I've been involved with the Energy Institute, the Carbon Capture and Storage Association, the Younger Enterprise, which is a charity helping students at school to set up businesses. And of course, as you've heard, a lot of involvement with the SPE Aberdeen section. But that's enough of me. What I have is a presentation for you in 4 parts. I'm going to talk about demand for oil and gas, how it's growing, and how the oil and gas industry is actually doing an extremely good job of meeting that demand. I'm also going to explain to you why I think there is actually plenty of oil to last us for centuries. You'll hear people talking about peak oil, but actually there's an awful lot of oil available. We'll talk about that. But then we'll talk about the big but, climate change. The oil and gas that we burn is causing a major problem for our planet. And then we'll take a look at the future and see what sort of changes I think might happen. So to start with, the source of the growing energy demand is a growing population on the planet. What you see here is data from the United Nations and its actual numbers up until 2024, and then projections beyond that. And what you see is, firstly, that over the last 60 or 70 years, the planet has added about 1 billion people every 12 or 13 years. We are currently sitting at about 8.3 billion people on the planet. But if you look to the future, there's a lot of uncertainty. Those blue lines are the extremes, which I'll explain in a moment, and the various projections that you see with the red lines and the yellow lines are various scenarios that the United Nations has mapped out. The reason for the blue lines is that there is a massive variation in the rate of reproduction around the world. At the one extreme, in the Republic of Korea, they are currently producing less than 1 child for every couple. What that means is that the population is shrinking and it's generally getting older. I'm sure you'll all be delighted to know that at the other end of the scale, Nigeria is one of the most enthusiastic at reproducing, with 6 children for a couple, and as a result, your population is growing. But if you look at the forecasts, in all cases, the expectation is that as you get more and more control over reproduction, that your rate of reproduction will decrease. What we know is that we don't really know. If the low projection is reality, there'll be a reducing requirement for energy in the future. If the upper projection is reality, there'll be a much growing demand for energy in the future. And that uncertainty is reflected in this image, where you see that although the rate of people dying is fairly easily predicted, the rate of childbirth in the future very, very uncertain, which gives us this big range. Now, all of those people generally want to get better off. At the lower end of the income scale, there's low energy consumption. So if you're a bushman in the Kalahari Desert or a Tuareg wandering around the Sahara Desert, generally your energy demand is met simply by biomass and maybe candles. Generally, when the sun goes down, you go to sleep. When the sun comes up, you wake up. Most people in the world live in a sort of middle income countries, and their energy demand is much, much higher. They will use biomass, but also kerosene and LPG to cook. They'll use biomass, so wood and coal, for heating. They'll have electricity supplies and be able to recharge batteries. They'll have basic things like refrigeration and air conditioning, and lighting is pretty well provided. And then at the very high end of the income scale, so places like Europe, North America, Australia, and Japan, we take energy completely for granted. I expect to be able to walk into a room and the electricity just works. I've got gas providing the heating in my home, and that's true for everybody. And most income and of energy consumption. If you multiply these two things together, population and demand, then what you see is this data, which is from the Energy Institute's Review of World Energy. And what it shows is growing energy demand over time. You also see that it's divided into the energy sources. So oil at a bit over 32%, coal at a bit over 26%, gas at a bit over 24%, and nuclear, hydro, and so on, giving much smaller fractions of the energy supply. A couple of things to point out. Up to the year 2000, it grew about 3% a year, and that was driven by the population rise. But then since 2000, it's grown at about 5% a year, and that's mostly because a very big country called China, its population has got better off, and it is now demanding more energy. What you also see is the renewables is a very small fraction of this energy demand. Realistically, hydrocarbons provide well over 80% of the energy that the world consumes today. So for anybody worrying about a career as a petroleum engineer, I would say, don't worry, at least not for many, many years to come. Now, what we have been very good at doing is providing the oil and gas to meet that growing energy demand. This is a graphic showing the distribution of proved oil reserves in the world. What you see is it's divided by country, by region, and rather counterintuitively, it's actually gone up every year as we have found more and more oil and gas, and we're able to produce more and more of the oil and gas that we find. There've been a couple of big things. So when the United States worked out how to do shale oil, big step up there in reserves. And when seismic processing technology improved, and offshore Brazil, we were able to find some very big oil fields beneath salt intrusions. This also had a big impact on reserves. What you can also see is how significant the Middle East is as well. You hold in mind that figure of 17 reserves right now. Gas is a very similar situation. The big difference is that Russia has a very big slice of the gas reserves, and as a result has been supplying Europe with much of its gas for decades, although since the war in Ukraine, there's been some lack of approval for that. There's also a lot of oil that we know about, but we haven't put onto proven reserves yet. There is some oil in very, very deep water, and this is mostly the focus of the big Western oil companies like Shell, ExxonMobil, BP, and Total. There's a small amount of oil and gas in high pressure and high temperature reservoirs, but to be honest, so small that it's not significant in the world order. There is an awful lot of oil, as you can see, nearly twice as much as we currently know to be proven in the very heavy oils and the tar sands. These are mostly in places like Canada, north of Calgary, and in eastern Venezuela. Shale oil and shale gas could probably give us 4 times the proven amount of oil and gas right now if it was worldwide. At the moment, it's mostly developed in the US. Most countries in the world which have potential for shale oil and shale gas have chosen not to develop because of some of the side effects, notably seismic activity from hydraulic fracturing. I mentioned biofuels for completeness. I think it's going to be very small in the future simply because we also need to eat. So we would be competing for land use with agriculture if we were to go for biofuels at large scale. Rather bizarrely, when we're talking about climate change, carbon capture can actually be used to inject the CO2 into oil fields, existing oil fields, and you would have about 2 billion barrels, so more than all the oil we know about at the moment, if we were to use that technology. New frontiers, places like the Arctic, are expected to hold the same again. And new technology, just getting better at producing the oil and gas that we have already found, is the source of a lot more oil. In summary, we could keep delivering the world's energy requirements using oil and gas literally for many, many decades, if not centuries into the future. However, as you're all very much aware, climate change is an issue. Whenever we burn this oil and gas, we release carbon dioxide into the atmosphere, creating the problem that we all know as climate change. This is a graphic showing the CO2 emissions of various countries. And if we superimpose that rising energy demand, you'll see that it pretty much directly overlaps all of that growth in CO2 emissions. So direct and obvious linkage between our growing energy consumption and the growing CO2 emissions. Now, data that is collected in Hawaii at a laboratory called the Mauna Loa Observatory records the amount of CO2 in the atmosphere. And what you see here is a graphic showing in black the the monthly average. No, take that back, the annual average, and the red lines showing the monthly average. And what you see with the red lines is that the CO2 concentration goes up in the winter when the northern hemisphere is burning a lot of oil and gas to keep warm, and it goes down as spring and summer arrive and the planet starts to grow an awful lot of greenery. But you also see the absolute numbers rising continuously. And if we look on a longer term, this is the CO2 concentration has gone from below 320 to over 420 in just the last 60 years. So a 1/3 increase in the amount of CO2 over that time. Mauna Loa is a good way of measuring this because it's a long way from anywhere. So middle of the Pacific, a long way from any major industry, and therefore regarded as a good average of the globe's CO2 concentrations. The other piece of evidence is that global temperature is rising. It's quite dramatic. This graphic shows the delta, the difference between the average temperature in the last century and the temperature in a particular year. So you can see to the left, it was generally below the average. Then about the middle of the last century, it sort of flipped and flopped a bit. But for the last 50 years, it's just been above the average. And in fact, the last 11 years are the warmest on record. And specifically, the last 3 were the hottest ever. So pretty clear evidence that it's getting hotter. This is another graphic showing average temperatures, and really it shows the same thing, that the temperature is rising. Now, the linkage between CO2 and temperature is the subject of literally thousands of peer-reviewed scientific papers. I happen to like this particular one because it's very visual. So this is data from the the periodic report produced by the Intergovernmental Panel on Climate Change, and it records data from the Vostok ice core cut in January 2023. This was cut in Antarctica. It went about 2.2 miles, so about 3 and a bit kilometers down, and it just took a plug of the ice. Near the surface, it looked like this. So compacted snow with brown layers, which are organic material washed from the atmosphere each winter by the snow in the Antarctic, and giving us a great source of information about the nature of the organic life on Earth in that particular year. As you go deeper, the pressure means that the snow compacts and it's a genuine ice core, but it's also got little bubbles of the atmosphere from the time it was deposited. So what's happened is scientists have been able to measure directly the CO2 content of the air, and they've been able to infer the temperature from the microflora and fauna in those brown layers, and they map it very, very closely. So you can see this is just one piece of evidence of how closely CO2 concentration and temperature are linked. Now, if we take a look at the long view, the temperature has actually been quite a lot higher than today in time. This is a logarithmic scale. Today is over on the right, and 540 million years ago is over on the left. So what you see is that in the times when there was little life on the planet and mostly we were a sort of big volcanic mass gradually cooling down, there have been much higher temperatures. But if you move over to the right, for the last couple of million years, actually, as we've had ice ages, it's been much cooler. But the pace of change that we're now imposing on the Earth system is almost unprecedented. And the range of predictions suggest that we could be anything from adding between 3 and 10 degrees C to the temperature on Earth. So quite a scary, rapid change in temperature. Evidence that it's getting warmer and predictions about it. This comes from computer models. So those of you familiar with reservoir simulation, very similar models modeling the atmosphere. And what you see is what a reservoir engineer would call the history match. On the left is a graphic showing the observed temperatures around the world when we hit 1 degree C of global warming. And on the right is the computer model of 1 degree C. So not brilliant, but not bad match. If you then run that model forward, what you see is that all models are predicting much, much higher temperatures in the northern hemisphere, particularly in the Arctic, but generally much higher temperatures everywhere. And this is likely to have a major impact on life as we know it. A bit of evidence that it's actually happening now, apart from what you see on the news every day with wildfires all around the world. This is some data taken about 7 or 8 years ago using LiDAR to measure where the top of the ice cap was in Greenland. And what you see is that all the red areas are where the ice cap is lower than it was previously. Blue areas is where it's got a bit thicker. And when you integrate it, on the left is a graph showing the decrease in volume of the Greenland ice cap. And as you can see, it's around about 4 billion tons of ice has melted. Now, this has contributed a sizable part of the rise in sea levels that we have seen over this time, and is evidence of the risk of all of the ice in Greenland melting. If that happened, it would add 7 meters to global sea level. So quite a scary proposition. And right now, if we don't do anything about the amount of CO2 we emit, well, it's just going to keep going up, up, and up again. Right now, we're emitting about 38 gigatons, which is billions of tons of CO2, potentially by 2050 as much as 55 billion tons of CO2 each year. So just adding to the problem unless we do something big about it. And why should we worry? Well, apart from the obvious, immediately visible changes in climate, there has been an episode about 55 million years ago referred to as the Paleocene-Eocene thermal maximum. There was a massive release of greenhouse gas. We don't really know whether it was methane or CO2. It was probably methane from volcanic sources. But what the geological evidence suggests is there was about a 5 degrees rise in average temperature in the world. And with it came between a 40 and 60% extinction rate of all living forms. So we're heading for this higher temperature range. And speaking as a life form, I'm kind of keen that we don't allow that to happen. So what does the future hold and what might we be able to do about this? Well, the first thing to say is energy sources are changing. As you heard earlier, wind is a significant source of energy. Solar is growing rapidly. There are even experiments going on with putting wind turbines underwater and harvesting tidal energy as a source of energy. With this energy comes a requirement to store energy. At the moment, we almost unconsciously store energy in all of the oil tankers and oil tank farms that are around the world. But if you've got your product, your energy source is electricity, then you have to store it in batteries, which could be large or they could be small. There are some small scale schemes pumping water up mountains to store electricity. And another possibility is to convert it into hydrogen and store it in salt caverns for use later. So different ways, just new technologies, new ways of storing energy. The way we use energy is changing. Right now I'm being driven in an electric car, which means that I'm one of a small number of people who are starting to adopt that technology. There are hydrogen powered trains where they use a fuel cell to turn the hydrogen back into electricity. So actually electricity is running the train. There's even been a couple of flights by aeroplanes that are powered by hydrogen. Airbus has an experimental plane that is entirely electric. And then finally, this is an aeroplane that actually flew entirely around the world, only driven by solar energy. Now, to be fair, it was one person. It took 7 months, so it's not going to replace your Airbus A380s just yet, but it illustrates the direction of travel of the technology. Renewables are growing extremely rapidly. This graphic shows an almost exponential growth in the use of renewables. So although right now they're a small fraction of the world's energy supply, I think over time they will become very, very significant. And it is really significant to note that, as an example, in Asia, the installed solar base is now greater than the installed gas-fired electricity generation base. So solar has come from nowhere in literally the last 5 years to be a major source of electrical energy. This is another relevant graphic. This is a day's supply of electricity in California. The yellow is the solar, green is wind, red is geothermal, blue is hydro, light blue is hydro, and then dark blue is batteries. So a huge economy in the form of California had an entire day supplied only with renewable energy. So things are changing. So what about the oil and gas industry? Well, clearly, we're a major source of energy in the world, and we have the big advantage that we know where this energy is. So there are some possibilities. We could decarbonize our oil and gas. You've heard about CCS, but you could also split the molecules into hydrogen, which you could use as a fuel, and then you'd just have carbon to dispose of, probably in landfill sites. But maybe you could do it in the reservoir, or you could do it at a coast. So lots of possible ways of decarbonizing. And I mentioned carbon capture and storage, a significant potential to dispose of the CO2 that way. We can store hydrogen and use that as our energy source. We're even using oil and gas technologies to explore for naturally occurring hydrogen. And we're absolutely using oil and gas technologies to develop geothermal energy. The most recent SPE board meeting was in Nairobi, and the board took a visit to the KenGen site about 3 hours north of Nairobi, where they're producing about a third of all Kenya's electricity requirements entirely by geothermal energy. So things are changing rapidly. So my view, last couple of slides now, you won't be surprised to hear that I think we're ruining our planet by burning hydrocarbon in every aspect of our civilization. And if we don't do something, the planet we live on is going to change dramatically, and not in a good way. I think something has to change. That could be low carbon alternatives to hydrocarbon. It could be by just reducing the carbon emitted by hydrocarbon. More likely, it'll be a mixture of both. At the moment, I'll be honest, I don't think the public is connecting. I think in most places people understand hydrocarbons are causing climate change, but they still want life to go on as we know it. driving their cars, flying their planes to go on holiday, having things like fancy vegetables and flowers flown around the world, and the ability to travel on cruise ships. The solution will be a mix of things. I think we'll be decarbonizing our electricity production. That's starting to happen simply because it is cheaper. And that is probably the most powerful driver of the change that's likely to happen. So gradually in electricity production, gas and coal will get phased out. Heat will also change, particularly electricity and hydrogen and energy storage likely to take over from natural gas as it is phased out. We'll be decarbonizing our transport again, simply because electricity becomes cheaper. We'll use less energy because we can insulate, we can improve our technology, and saving energy saves money. And probably most uncomfortable, I think we will have to have changes in lifestyle, how much we travel, and the sources of our food, the sources of packaging, definitely a lot less clear in my mind. So I hope I haven't depressed you too much with the future for the oil and gas sector. I do think that we have a part to play, a very big part to play, but I also think we have to make changes which are at the moment not being made fast enough. So that concludes my presentation. I would be very happy to take a few questions and answers. I have about 10 minutes available before I will have to drop off. So thank you very much.
Yeah, thank you very much, sir. The 2028 international president. He has done justice to our team for this year, building today's petroleum with tomorrow's energy solution, where he spoke about the growing demand, flexible supply, the future, and all. So, without wasting much of our time, I'll be handing over to Edgar Yahweh to engage us with the question and answer session. So, yeah, you have the floor.
Thank you so much. Thank you so much, Mr. Ian Phillips, for the good presentation. I may say I was just wondering on where all this information is coming from, but I appreciate your slides, and I've liked the way you've organized your slides and the data analysis. It was properly organized. The charts and graphs would explain it all. Thank you so much. And I'll call up the questions from my colleagues, whichever person that is online. We have 10 minutes for the question and answer. You can do the same. You can either type the question in the chat, or you can unmute and say it verbally. I would personally give in my question first, as the rest are prepared to give in their questions. I am so much interested in carbon capture, and I've done a project on carbon capture before. And I have loved that it is maybe the hope and the future of the oil and gas in to do with in fact, climate change and solving all issues to do with climate. And my question is, I've had several challenges. I'm using one of the softwares called SpenHysys. And the challenges is, I normally face challenges to do with the data because this software needs so much to do with input. And if you're running a simulation for a country like Uganda in East Africa, where there is less of refineries, less of carbon capture information, you'll find you don't have the data for the input to do with the temperatures, what are the amounts of carbon that are likely going to be produced, what are the types and compositions of that kind of carbon dioxide going to be produced. So the main issue and main problem in our studying to do with carbon capture is lack of information. And at times when you try relating to some of other refineries, times are not matching to do with the weather, to do with the temperatures and the pressures. So if there could be...
Just one moment.
Sorry? I don't know where you managed to get that question, but I think I was kind of clear.
Yeah, just hold on one moment. I'm just connecting on my phone so I can leave the car. One moment.
All right. As the rest be preparing their questions in the chats, I'll try to read them very fast, given that Mr. Ian Phillips is traveling, and like some of us are not traveling, but let us try to do it very fast. I don't know whether you're ready.
Can you hear me now?
Yeah.
Okay, so I've switched from my laptop to my phone, so I'm able to answer Q&A.
Yeah. My name is Yao Edgar, the president of the Society of Petroleum Engineers from Bara University, which is in Uganda in East Africa.
Yeah, so I did hear your question, so I'm happy to try and answer it.
All right, so I can come again. My question, you want to answer it? Did you hear part of it?
No, I did hear your question. So your question was about how do you do CCS when you've got very little information? And
yeah, exactly.
I think the challenge that you have is a very real one. It's real all over the world because if you're going to store your CO2 in an aquifer, which is the most likely place, you just don't have the data. And so as a result, you're going to have to do exploration in the same way that you do for oil and gas, except you're now going to be exploring to find information out about about an aquifer. So you're looking for porosities, permeabilities, pressures, temperatures, and so on. So the simple answer is it's going to be more expensive. You're going to have to drill exploratory wells so that you have the confidence to actually do the carbon capture. Does that make sense to you?
Yeah, makes sense.
I know it's awkward, but
some other questions in the chat. Thank you so much, sir. Please, how do we transition into system controls, instrumental and automation, the oil and gas fields, and what approach can we take? I don't know whether you're able to read the questions in the chat, but I think I'll just read some of them, or if you have not noted them, then you can get them from there as well. Considering carbon emission, distorting the climate changes, if focus on wind, solar, hydrogen, and electricity, what will be the future of oil and gas industry as well as its professionals, employees? I think that one is asking about the future of oil and gas industry related to the alternative.
Yeah. So I think so automation is absolutely happening. It's coming, and more of it. And that automation, I would extend that across the use of AI to evaluate what might happen with fields, both subsurface and at the surface. That's happening today, and who need to be able to understand what's happening very much more rapidly. They're going to get a lot more information a lot more quickly. Looking forward, I think that trend will continue, but I do think that there is going to be oil and gas for decades, because we can't just magically turn off civilization as we know it. If you just think of your own days, you travel on public transport, or you maybe have a car. If you're lucky, you fly to another country to study. All of these things, they burn hydrocarbons. So the world is very, very dependent upon these hydrocarbons, and we are going to still be producing those for decades to come. Yes, how we produce it is going to evolve as AI and automation become ever more prevalent, but it's not. It still needs people to make decisions, to commit to the investment in things like drilling for the oil and gas. So I think there's a very, very exciting career ahead for anybody with oil and gas and petroleum engineering related skills.
Okay, perfect. I think that is kind of clear. And the other, last question is if the ultimate goal of energy transition is net zero emissions, should petroleum engineers focus on making oil and gas cleaner through technologies like CCS, or should we be preparing for the future where oil and gas production is no longer the center of our profession? I think he's trying to say that net zero emission, or we just do CCA? Yeah.
So I think the simple answer is yes, all of the above. So I think that as petroleum professionals, we absolutely have to understand the damage that CO2 is causing to the planet, and we absolutely have to make ourselves part of the solution to that problem. But that doesn't mean we forget about the process of finding the oil and gas, because obviously we still need that. So I think, if anything, the energy transition extends what an oil and gas professional does, with them focusing on oil and gas. But remember what I commented on, what the previous presentation also talked about. Oil and gas skills are just as relevant for geothermal energy, for CCS, for hydrogen storage, if it happens, for hydrogen exploration and production. So there's a lot of potential for different applications of the same skills. So, I mean, I'm by nature a bit of an optimist, but I think I can legitimately and genuinely see a lot of opportunities for anybody with subsurface skills in all aspects of the energy transition, including oil and gas.
Okay, thank you so much. We can see already moving, and we apologize for the hard travels we are giving you. I think we are done with the questions. The very last one, but I think, is there a way of this detoxification of carbon emissions? I think that is to do with carbon capture.
I think carbon capture means that you've already produced carbon dioxide. So carbon dioxide is produced just by the chemical process of burning oil and gas, whether it's in an engine or a heater or whatever. And the CO2 is what's causing the problem. Now, the idea of detoxifying it suggests that you're sort of doing something to change the chemical properties. And I think, given the scale of CCS or of CO2 emissions, I think that's unlikely. What I do see is the potential to use carbon dioxide to make other products. So there's an awful lot of chemicals can be made, or use CO2, often with hydrogen, as a sort of building block for producing other chemicals. So not a detoxification, but let's say find a good way of using the CO2. That's, I think, a lot of potential in there.
Thank you so much. And I think we are done with the questions. I don't think there's any other question. Thank you so much for your presentation. It has been an exciting one. And,
good. Well, I appreciate the invitation, and I will now drop off and go and have my dinner. Thank you.
All right. Thank you.
Bye-bye.
Bye-bye. Back to you, Mr. Chair.
Yeah, thank you very much for this engaging session. So right now, we'll be moving on to the networking session by Ayomide Peters. Thereafter, we'll be having the announcement session by Gideon Joseph, then the photograph session. So let's move on to the networking session now by Ayomide Peters. So we'll be adding that. And if you enjoyed the session, can I get reactions from you before we continue? Yeah, I can see hands flying. Yeah, thank you very much. So Ayomide Peters, you have the floor.
Okay, good evening, everybody. Please confirm you can hear me. Okay, thank you very much. My name is Peter Ayomide, as you said. I'm opportunity to be here today. I'm the president for SP Redeemers University, and I'll be handling this networking session right now. So very quickly, I know from the topic and the theme of this meeting, we're dealing on how we can talk about future energy leaders. And I'm sure from everything we've heard here, I'm on this call presently. I'm together with some future energy leaders. I mean, we have the engineer from PTI that has spoken to us. He's also entering into the industry and also advanced in himself. We also have our 2028 SPI president, how we talked about his journey from a civil engineer, like migrating into a petroleum engineering student and everything. So I'm sure we have so many energy leaders amongst ourselves here. So very quickly, for those of us that want to connect, we're going to be having a virtual connection session. That's a virtual networking session. So we can go to the chat box and we can type in our name, our school. So whatever platform you want to connect with, you can drop it there. Either your LinkedIn, you can drop your LinkedIn profile or your WhatsApp number if you're comfortable with that, or even your IG. So I would like us to go straight down to the chatbot session. Everybody just drop your name and whatever platform you want to be connected with, either LinkedIn or WhatsApp or IG for those of us that use these platforms. You're just putting your full name, even your schools. I know there are several schools together with us here on this platform, on this call right now. So if you have opportunity or you have chance, you can talk about just your name, your school, and whatever platform. Okay, yes, thank you, Godswill. Godswill has dropped something, dropped his WhatsApp number. Godswill with Justice, petroleum engineering student, he has dropped his WhatsApp number. So any other person that wants to connect with him can take his detail from there. I think I should also do that myself. I have just 5 minutes for this, and I think we're going to end around 6:33 p.m. 6:32 p.m. So while we still wait, I'm waiting for the rest of us that want to connect. Thank you to everybody that is dropping. Oh wow. Oh wow. Oh wow. So we can head over there. For those that want to connect through LinkedIn, you can just go and tap their link and connect with them right now. So I just connected with Great Akuma. On LinkedIn. So for the rest of us, we can do that. I think we have about 2 minutes left. Okay. Wow. So many future energy leaders here. You can just take a screenshot too, in case, so that you don't lose this after this call, because you might want to need. Oh, I can see Christabel too. Shout out to Christabel from Williams University too. Okay. I think we still have about 1 minute left, 1 to 2 minutes left. And after that, we'll go on to the next session. But right now, I can still keep sending anything. Can keep sending anything. I said, so that we don't lose contact. You can take a screenshot. I mean, it's a whole lot. Starting from Godswill, I can't even count. I'll be glad to say I met some of these people on this call later in the future because I have their contact and their connect. Okay. So over to you, back, sir.
Yeah, thank you very much. Thank you very much, Ayomide, for this wonderful networking session. So because I am the moderator of this session, I'm not really able to, but I know I'll be able to get it. So I'm not really able to copy some numbers. And I already sent my details to the chat box. I hope you see that there. I am Alamin Abubakar, and I am the president of the Society of Petroleum Engineers, Lagos State University. So right now, we'll be moving on to the next thing on our agenda, and that is announcements, which will be made by Gideon Joseph, the president of SP Udom. So yeah, Gideon Joseph, you have the floor to speak. So are you on the call?
Yes.
Yeah, thank you. So you can speak. So you have about 3 minutes to that.
Okay. Good evening, everyone.
Good evening. We can hear you.
Okay, I'm Gideon Joseph, the president of SPDOM chapter in Tanzania, and I'll be talking through the announcements. First of all is reminding about SP membership. It's very important to students and young professionals. Through SP, you get scholarships, internships, mentorship programs, and so on. So if you are interested in becoming an SP member or renew your membership, you can scan the QR code from the slides, or you can follow any reader around you to give you how to register in the SP. And secondly, it's about tomorrow program. We will have Dr. Chukwemeke as our guest speakers. So I encourage you everyone to join on time so we can engage and ask questions. Okay, that will be the end to the announcement. Thank you very much, and I wish everyone a productive session. Thank you.
Yeah, thank you, Gideon Joseph, for this wonderful announcement. So you mentioned that if you are not yet, because this session was open to both non-SP members and SP member itself, where we have industry leaders and all. So if you are not yet an SP member, you already mentioned the benefits of being a member of SPE. So you can scan through the QR code to become a member. So the link to register would also be sent to the chat box. So yeah, right now we're moving on to the photograph session, and Tukur Aruna will be handling the photograph session. So let's get ourselves ready. Let's get our faces ready, because I'm sure we have beautiful faces on the call right now. So we can have the photograph and networking session now. Yeah, so Aruna Tukur, the president of SP ATBO, you have the floor to speak and engage us on the photograph session.
Okay. Good day, everyone. My name is Tukur Aruna, President SP ATBU chapter. Before we proceed, I would like us to take a moment of capture some memories together. The program is not just about the conference. It's also about the collaboration, friendship, and unity between our chapters. As different representative of our various chapters, please let's us all open our camera and take the photo shots, please. Can we do that for a moment before we proceed? Many people are not showing their face, please. David, success. Ifebella, many people are not showing. Can we please cooperate and show our faces, please? I'm having few.
Yeah, I can see people are now showing their faces. Can you see that from your end?
Can we show thumb of SP, please? Can we? Okay, that is all. Thank you, guys. Thank you very much. Thank you for your cooperation. Thank you.
Yeah, thank you very much, Tukur Aruna. Thank you very much, Chukwur Aruna. So right now, we'll be moving on to the next agenda, and that is the final program for today's session. It is the closing remark by by Eseke. Please, can you hear me?
Good evening, everyone. Can you hear me?
Yeah, so by Eseke Chukwuemeka Prince, the president of SPE, Southern Delta University. They are the hosts for today's wonderful session. So I'll be handing over to Eseka to give us the closing remark. Yeah, thank you.
Okay, good evening, everyone. My name is Eseka Chukwuemeka Prince. I'm the president of SPSDU, and I want to say a big thank you to each and every one of you for creating time out of your busy schedules to be here. All of you here today made today's program a success. I want to say God bless you all. I want to especially appreciate our guest speakers for first off accepting to be here today and also imparting knowledge on us. I believe a lot of us here have learned a thing or two. I believe our perspective before coming to this program, some of us we now have different perspective of what the oil and gas industry holds for us tomorrow. Tomorrow is also a wonderful day for the day 2 of the session, and I'm promising you that tomorrow will be more powerful than today. Come with your book, your pen, come with open mind to be impacted by Dr. Chukwuemeka. A lot of us here know him, and he's a very wonderful speaker. So thank you all for creating time to be here, and I'll also see you all tomorrow here. Thank you all. God bless you all. Have a wonderful and great evening. Thank you. Thank you for a wonderful session. Thank you all.
Yeah, thank you very much, Prince, for this. So right now, we've come to the end of today's program. So thank you very much for joining today's session. We'll be expecting you all and your friends for tomorrow's session. Yeah, thank you very much. So you can now leave the call. And if you've not gotten the networking session numbers and all, so you can still have the time to get them before you leave the call. The messages are still available there. Yeah, thank you.